So in this video, we're going to talk about using quadratic equations in a variety of forms to make a quick sketch of the graph of their parabola. So here we have an equation in factored form. And if you remember, factored form gives us information about the x-intercepts of a certain graph. So here are x-intercepts here. So we have an x-intercept at -3, 0, and another x-intercept at +1, 0. And the question is asking us to sketch the following quadratic function using axes intercepts only. So we already have our x-intercepts without doing any work at all. We've got them. We've got an x-intercept at -3, 0 and an x-intercept at 1, 0. Now the other axes intercept that we have to be concerned with is our y-intercept. So the point at which this parabola is going to cut through the y-axis. And our method for finding the y-intercept is always the same, regardless of our equation. To find the y-intercept, we want to set x equal to 0 and solve for y. So here we've got y equals 2 onto 0 plus 3 onto 0 subtract 1. The reason we do that, set x equal to 0, is because if the graph is crossing the y-axis, we already know that the x-coordinate at that point is going to be 0, regardless of what the y-coordinate is. So we're able to set x equal to 0 here and solve for y. So simplifying this out, we've got y equals 2, 0 plus 3 is +3, 0 subtract 1 is -1. So we've got y equals 2 multiplied by 3, so +6, multiplied by -1, y is equal to -6. So we have a y-intercept then at 0, -6. So putting all these pieces together for doing a quick sketch, we need to draw our y-axis, our x-axis. Probably actually want our y-axis to be a little bit longer here. We put our x-intercepts on here, so we know it's going to go through at -3, and it's also going to pass through again the x-axis at +1. And our y-intercept is going to be at 0, -6. So we know just based on looking at where our points are, but also because our stretch factor here, our a value is positive, that we're going to have a smiley face, and we're able to draw a quick, rough little sketch of this parabola coming down, passing through the y-axis, and back up through the x-axis. And that's a good enough sketch. It's well labeled. You can see the x-intercepts. You can see the y-intercept. This is fine. The question doesn't require anything more than this. So in this example, it says use the vertex and the y-intercept to sketch this equation. Y equals -2 onto x plus 1 squared plus 4. So right away when I look at this, I see our stretch factor is negative. So we know we're going to have a graph that opens downwards. We're going to have a frowny face parabola. And this equation here, unlike the other one, is not written in factor form. It is written in vertex form. And when an equation is written in vertex form, just like the name suggests, it gives us some information about the location of the vertex. And the vertex is going to occur at this point is the x-coordinate of the vertex, except we changed the sign. So our x-coordinate is -1. And then this guy on the end is our y-coordinate of our vertex, +4. So our vertex is going to occur at -1 and +4. So we have that information right away, just like we did before with our x-intercepts. When it's in vertex form, we don't have to do any work to find the coordinates of the vertex. We have to do a little bit of work, however, to find the y-intercept, but the method is exactly the same. So like I said before, when you find the y-intercept, what you're going to do is set x equal to 0 and solve for y. So we've got y equals -2 onto 0 plus 1 squared plus 4. So I've got y equals -2 plus 4, which is 2. So our y-intercept is occurring at 0, 2. So here I'm going to just do a rough sketch. I've got my y-axis. I've got my x-axis cutting across here. I've got my vertex at -1, 4. Here's my vertex. Negative 1, 4. And I have a y-intercept at 0, 2. So again, just a rough sketch. I know my vertex is up here. Now I'm going to be cutting through my y-axis. Here we go. There's a very rough sketch, but it is labeled, of my parabola, mapped out by this equation, y equals negative 2 onto x plus 1 squared plus 4. In this third example, it's asking us to find the coordinates of the vertex of this equation. If this equation was in vertex form, we'd have it pretty easy. It would be a simple task of just writing down the coordinates of the vertex. But this equation is in standard form. So there's two ways we could go about this. With an equation in standard form, we could complete the square, but you guys know how I feel about that. I'm not a big fan of completing the square. So I would use our shortcut method. And the shortcut method is that we know an equation to find the axis of symmetry, or in other words, the x-coordinate of the vertex. The x-coordinate of the vertex can be found by doing negative b over 2a. Remember, this is our a value, this coordinate of x, or this coefficient of x squared is our a value, coefficient of x is our b value, and then this number on the end that never changes is our c value. So in this case, if we want to find the coordinate x-coordinate of our vertex, or our axis of symmetry, we've got negative b, so negative 8, over 2 multiplied by our a value, which is 2. So we've got positive 8 over 4. So our x-coordinate of our vertex is 2. So we have that piece of information. We have the x-coordinate of our vertex. We need to find the y-coordinate of our vertex. And the way that we do that is just to take our original equation and plug 2 in for x and solve for y. So we want to know what y is when x is equal to 2. So we've got y equals 2 onto 2 squared minus 8 times 2 plus 1. So we've got 2 multiplied by 4 minus 16 plus 1. So we've got 8 subtract 16 plus 1. So there's 8 minus 16 is negative 8 plus 1 is negative 7. So our y-coordinate of our vertex is negative 7. So our coordinates of our vertex are at 2 and negative 7. So again, you could have gotten that same answer by changing it into an equation in vertex form by completing the square, but I think this is easier. It has less room for error and less steps to remember. So we find our x-coordinate using negative b over 2a, and then we plug that x-coordinate into our original equation to find our y-coordinate of the